Alright, let's do this. Let's do this next section. Chapter 13, section 3, I believe. Let's open that up real quick. Bam. Improving our I.O. project. By I.O. project, I believe they mean the mini-grep project. In chapter 12? 12. Let's move this over. With this new knowledge about iterators, we can improve the I.O. project in Chapter 12 by using iterators to make places in the code clearer and more concise. Let's look how iterators can improve our implementation of the config new function and the search function. So yeah, we're going to see how iterators can help us change things and make things more clear in our mini-grep project, which is the project they're talking about in Chapter 12. Removing a clone using an iterator. In listing 12-6, we added code that took a slice of string values and created an instance of config struct by indexing into the slice and cloning the values, allowing the config struct to own those values. In listing 13-24, we've produced the implementation of the config new function as it was in listing 12-23. So yeah, this is what it used to look like, and if I move this over and open up my editor, I think I still have it right here. So that's how we ended it. So they are correct. And we can read through this real quick. We have implementation of config, right? We have our, I believe it's called associated function, new, which just creates a config for us. We pass in the args and we return a result that is a config or a string, seemingly with a lifetime of indefinite or forever. And that string, if I remember correctly, is used as our error message. So we said the arguments have to be less than 3. Sorry, no. The arguments have to be greater than 3. If they're less than 3, we return an error, and that will be the error message for the program. Then here is what they were talking about just now, where we take these two values and we clone them. And this line is because near the end of chapter 12, we wanted to test out using environment variables. So we're checking to see if case insensitive is set or exist. And at the end, we return an OK with a config that has been initialized with the query, which is the first argument. Well, I mean, 0 is the first argument, which is the name of the program, but the first argument that's passed into the program. And the second argument that's passed into the program, which is the file name. And then case sensitivity is based on this Boolean. Moving onward. At the time, we said not to worry about the inefficient clone calls because we would remove them in the future. Well, that time is now. I actually do not recall them saying that, but they probably did. Okay. We needed clone here because we have a slice with string elements in the parameter args, but the new function doesn't own args. To return ownership of a config instance, we had to clone the values from the query and file name fields of config so the config instance can own its values. Alright, so what they were stating here is the old problem is why we use clone here. And we use clone here because we needed the config to own both query and file name. But since the arguments were originally owned by this slice, we had to clone them before we can pass them in, and the clones are now owned by the config. With our new knowledge about iterators, we can change the new function to take ownership of the iterator as its argument instead of borrowing a slice. Okay. So with our new knowledge, instead of doing this, we can seemingly create an iterator off of the arguments, which I guess is a slice that we can iterate over. And then config can take ownership of the iterator, which will prevent new allocations of query and file name. We'll use the iterator functionality instead of the code that checks the length of the slice and indexes to specific locations. This will clarify what the config new function is doing because the iterator will access the values. That I'm not sure about. We'll have to see it in practice. Once config new takes ownership of the iterator and stops using indexing operations that borrow, we can move the string values from the iterator into config rather than calling clone and making a new allocation. So here is where the meat of what they're trying to say is. They're saying here that instead of using indexing operations, which was calling args at index 1, calling args at index 2, and then copying it, we can directly move the string values from the iterator into config rather than call and clone. So once we have the iterator, we can directly move the instances of the values associated with query and file name directly into config without cloning it at all. And that's written here. So using the return iterator directly, open your IO project's source main.rs file, which should look like this. Okay. So they're doing in the main function. So let's try this out. Actually, first let's try to remember what mini-grep did. Run, poem, output, text. Oh, I was writing it to a text file because we could write it to a text file. It's a little bit bigger. Let's not point it to a text file. Are you nobody? To how jury to be somebody. Okay, so that still works. Now that we know it still works, let's do the modification that they suggest. And let's find our main. Oh, that's in the libs. Here's the main function. Cool. So now that we found our main, let's see. We have let args spec string, environment args, collect, that we have, config new, pointer to args, unwrap error, eprint for the printing out the errors in the process code, yes. So we confirm that our IO project does look like this at the very beginning. Moving onward. We'll change the start of the main function that we had in listing 12-24 to the code in listing 13-25. This won't compile until we update config new as well. Okay. So they remove the environment args collect. I see. Delete. And instead, in the config new, they pass it in directly. Environment args. Okay. And that won't compile because it's not the type that we want. Understood. The environment args function returns an iterator. Rather than collecting the iterator values into a vector and then passing a slice to config new, now we're passing ownership of the iterator return from environment args to config new directly. I see what they're doing there. So earlier when we had the let in the arguments, hold on, I can show you. Earlier when we had this, we already had access to an iterator and we were already calling collect on it, which then made all of the items in environment args into a vector, but the vector had ownership of it. And because it had ownership of those values that we wanted, we then had to clone them out. However, if we skip this step here and do it within config, then the config will directly have ownership of those values. We won't have a middle party to go through. So removing this and instead just passing them directly into the config. That makes sense. Next, we need to update the definition of config new. In your IO project source/libs file, let's change the signature of config new to look like listing 13-26. This still won't compile because we need to update the function body. Alright, go to libs, function new, and now we have a new argument. So our args is now mutable because it's an iterator. In iterators, you have to, the indexing changes while you're iterating through them, so they have to be mutable, seemingly. Standard library, environment, args, and then the ending part of the signature we're returning is still the same, a result with config and or a static string. Okay. The standard library documentation for the environment args function shows that the type of the iterator it returns is standard library environment args with capital A. We've updated the signature of the config new function so the parameter args has the type standard library environment args capital A instead of a pointer to a slice of strings. Because we're taking ownership of args and we will be mutating args by iterating over it, we can add the mute keyword into the specification of the args parameter to make it mutable. So they're just reiterating what I said with the exception of this first part. So the reason why they use this as the type for the arguments now being passed into config is because they went to the documentation of environment args and realized that the iterator has the return type of this. So this is the type of the iterator. And they explain mutable, which I also explain. It's just that iterators, because you have to iterate over them, numbers are changing within that struct, so it is mutable. It is changing, mutating, and thus we have to use the mute keyword in front of args. Moving onward. Using iterator trait methods instead of indexing. Next, we'll fix the body of config new. The standard library documentation also mentions that standard environment args, capital A, implements the iterator trait. So we now know we can call the next method on it. Listing 13-27 updates the code from listing 12-23 to use the next method. I see. So what they have here, we just walk through it. Arguments next, because the first argument is always the program name. You don't care about that. And that's always going to exist in a command line application. So you don't need any error handling around it. And then the next argument should be the query. So we do a match on next, and in the ARMP you have if it exists, return it. If not, return the error, which we're already handling. And we do a similar thing for file name. We have a match, we have the ARM. If it exists, return it. If not, give it a specific error. And then case insensitive or case sensitivity has not changed. And then case sensitive, the Boolean for the environment variable, hasn't changed at all. So yeah, we can write that real quick. So you guys disappeared. And now we do args.next. Let query equal match args.next. Let's finish writing next. And then we have our arms, some arg, and if it's none, return error. Didn't get a query string. And then we do the same thing for file name. We're doing a match args.next next. Some arg none, return the error. Didn't get a file name. Then everything else should be the same. And I think this should work as expected now. So yeah, we ran it and we got the same output as before. This is sort of moved over. Oh, because it's not. There you go. Same output as before. And now we can check to see our error messages, right? So we do not have a file name. Didn't get a file name. And if we do not have a query string, we didn't get a query string. Cool. So everything seems to be working as expected. Let's continue onward. Remember that the first value in the return value of environment args is the name of the program. We want to ignore that and get to the next value. So first, we call next and do nothing with the return value. Second, we call next to get the value we want to put in the query of the config. If next returns a sum, we use a match to extract the value. If it returns none, it means not enough arguments were given and we return early with an error value. We do the same thing for file name value. So yeah, we already went over it, but this is what they're talking about. Calling next. This is the arguments name, the command line file, the name of the file that we're running. Query is the next one. We either get it out from the iterator or we raise an error. Do the same thing for file name, and then we just pass query and file name into the config. Making code clearer with Iterator adapters. We can also take advantage of iterators in the search function in our IO project, which is reproduced here in listing 13-28 as it was in listing 12-19. So let's assert their claims. Let's find our search, and yeah, that looks pretty much identical. Okay, let's go through it real quick. We have public function search has a lifetime because we're passing in references to strings, and which means the vector also has to have a lifetime because it's going to be associated with one of the items that's being passed in this reference. Okay. Let mutable results equal vector. We're creating a new vector to put our results in. And then for line in contents.lines, we're iterating over the lines of the content. If line contains query, if it contains our query string, results plus line. Put that line into the vector. And then we're returning results, which is the vector of these lines. Okay, understood? We can write this code in a more concise way using iterator adapter methods. Doing so also lets us avoid having a mutable intermediate results vector. The functional programming style prefers to minimize the amount of mutable state to make code clearer. Removing the mutable state might enable a future enhancement to make searching happen in parallel, because we wouldn't have to manage concurrent access to the results vector. Listing 13-29 shows this change. Okay, so what they're saying here is one of the pitfalls of the method that we're using earlier, this one, is that we have to create a mutable vector for like the intermediate carrying of this data, when we probably wouldn't have to. We change the method, change the way we're doing things using iterators and iterator methods. And if we ever wanted to, not necessarily with this code because out of scope, but in other code, if we wanted to make the process parallel, if we use this method, then we have to manage having mutable states, which could get hairy. So instead, they want us to use filter, which then cuts things down. So we do content.lines, and we can create a filter line and line that contains query string, and then we can collect, and then we're done. And the signature doesn't have to change because we're still returning a vector. So yeah, this makes a lot of sense. So we can delete all of this and drop it down to, I guess technically one line. I mean, they put it on multiple lines, but it's just technically one expression, I think. So content.lines, let me spell that right, dot filter, and then we have our closure, that's what it's called, line dot contains query, which we're pulling from the outside environment here, dot collect. And with that change, everything should work. Let's see. And it does. So search still works. I'm really curious as to what they're doing under the hood, because this is stating that line is a pointer to a pointer, which seems kind of hairy to me. But I don't have to deal with it. Okay. Oh, and just a refresher on filter. What filter does is it checks the condition. So we have our closure, and then we have a condition, which is either going to return true or false. And if it returns true, then the filter says, okay, you pass, and we can keep you. If it returns false, it just gets rid of them. It skips over it. And we just collect activates the iterators, because iterators are lazy. And we get a return value of our vector with the things that evaluated to true in the vector. Recall that the purpose of the search function is to return all lines in contents that contain the query. Similar to the filter example in listing 13-19, this code uses the filter adapter to keep only the lines that line.contains query returns true for. We then collect the matching lines into another vector with collect. Much simpler. Feel free to make the same change to use iterator methods in the search case insensitive function as well. Okay. So what they're stating here is basically what I just stated in terms of how this works. But given that we have another function with similar functionality, we can use the same logic here. I won't do that because I'm running short on time, but yeah, just note that. The next logical question is which style you should choose in your own code and why. The original implementation in listing 13-28, or the version using iterators in listing 13-29, most Rust programs prefer to use the iterator style. It's a bit tougher to get the hang of at first, but once you get a feel for the various iterator adapters and what they do, iterators can be easier to understand. Instead of fiddling with the various bits of looping and building new vectors, the code focuses on the high-level objective of the loop. This abstracts away some of the commonplace code, so it's easy to see the concepts that are unique to this code, such as the filtering condition, each element in the iterator must pass. But are the two implementations truly equivalent? The intuitive assumption might be that the more low-level loop will be faster. Let's talk about performance. Alright, so here they're just going over the logical question of, we just showed you two different ways of solving the same problem. And I'm glad I didn't change it because now I have both of them here. We have the iterator style, bam. And then we have we write it out ourselves and iterate and create our vector ourselves style. Which technically goes all the way down to here. these both solve the same problem, at least for us in this context. But knowing that there are two ways of doing it, we now have to ask ourselves, which style should we prefer? They don't give us an answer, but what they do try to hint at with this little cliffhanger at the bottom is we may assume that this style is faster in terms of speed and rust. I don't make that assumption because I know iterators are typically faster in most languages. But, I mean, they're probably going to talk about that in the next section. Till then, I hope this was useful. Hope it was entertaining. If you like it, subscribe. Inside of that, peace.